Hi students, this is Navin. Today I am going to explain the charging process of a capacitor in a RC circuit. In which type of circuit is this? RC circuit. RC circuit means in any electric circuit consisting only resistors and capacitors. That type of circuit is called as a RC circuit. Now, with the help of RC circuit, how we can charge the capacitor? If you observe this electric circuit having capacitor and resistance, and these capacitor and resistance connected to the cell, the EMF of the cell is given by E. This is the positive terminal and negative terminal, and here the switch is connected here. Here the switch is in open condition. Switch is in open condition means there is no current flowing through the circuit. Initially, we can take the capacitor is a uncharged capacitor. There is no charge on this capacitor. It is a uncharged capacitor. While the capacitor is connected to the cell with an EMF E, with the help of the resistor, what will happen if you switch on the circuit? If you just switch on the circuit, initially, if you switch on the circuit, just after switch on the circuit, what will happen? The current flowing through the circuit, let us assume the current the current flowing through the circuit at initial case, remember initial case, the capacitor offers zero resistance, nothing but initially at t is equal to 0, the capacitor offers zero resistance in this condition. Zero resistance means, in other words, you can say that the capacitor acting as a conductor here. The capacitor acting as a conductor, nothing but it will become a short circuit. This portion becomes a short circuit. Whenever the capacitor offers zero resistance, it will acting as a conductor and this portion becomes a short circuit. In that case, T is equal to 0, the charge Q is also is equal to 0. Whenever it will be short circuit, the maximum current flowing through the circuit, the maximum current Imax is given by EMF by resistance. Imax is equal to E by R. Remember, initially, whenever the switch is closed, just closed at that particular condition, the time t is equal to 0, charge is equal to 0, the capacitor offers a 0 resistance, it will become a short circuit. Due to that short circuit, the current flowing through in a circuit becomes a maximum current. Imax is equal to E by R. After some time, what will happen? The charges accumulate on the plates of the given capacitor, and this plate becomes a positively charged and this plate becomes a negatively charged. After some time, at t is equal to 0, q is equal to 0. After some time, let us consider at t is equal to t, the charge is accumulated on the both plates of the capacitor. Here the charge we can consider the q, and the current we can consider current is equal to I. We have to find out how much charge accumulated on the plates of the capacitor and how much current is passing through the capacitor. We have to find out this one. Is that clear? Next, in third case, after a long time period means you can consider at t is equal to infinite. T is equal to infinite, what will happen? At t is equal to infinite, after some time the capacitor fully charged. After fully charged, the capacitor opposes the remaining charges for accumulation of the charge on the capacitor plates. Nothing but at t is equal to infinity, the charge Q becomes maximum. Nothing but Q becomes Q naught, where Q naught is the maximum charge. Q naught is the maximum charge on capacitor. Q naught is the maximum charge on capacitor. In this case, what will happen? This capacitor does not allow any current flowing through it because it is already maximum charged. In other words, you can say that here the potential difference it will become C. Here these two are equal. There is no current flowing through the capacitor and this part becomes a open circuit. This part becomes a open circuit. Due to this, there is no current flowing through the circuit. The current I is equal to 0. These are the three conditions at t is equal to 0, q is equal to 0 because capacitor offers 0 resistance, the maximum current flowing through the circuit. In second case, let us consider at a particular time t, the charge will be q, the current will be I. You have to find out how much charge. In this lecture, we have to find out how much charge passing through the capacitor at a time interval of t, and you have to find out I also. And next case, after a long time period, if the t becomes infinite, what will happen? The charge becomes maximum. Q is equal to Q naught, the maximum charge on capacitor accumulated. Is that clear? In that case, the capacitor acting as a open circuit. We already know that in open circuit, the current I is equal to 0. These are the three cases, but our requirement is you have to find out this situation. You have to find out the charge, how much charge accumulated on the capacitor in this situation. Now, how to find out? How to find out the charge accumulated on capacitor plates at time is equal to t. For that, if you observe the circuit, it is a loop. I want to apply the KVL to this loop. I am applying KVL. By applying KVL to this loop, we already know that KVL, if you have any doubts in KVL, you can check the previous video in my channel. Is that clear? Now, this is switches. If you apply KVL, what will happen? The traversing direction, the assumed direction, I will take a clockwise direction. This is the clockwise direction, -2 plus it will becomes plus E, and here the capacitor plus Q2 minus Q. Here we have to write down every term in the form of potential difference. We know that C is equal to Q by V. Here potential difference V is equal to Q by C. It will becomes Q by C. Every term in the form of potential difference only according to KVL. And if you observe here, the current direction, our traversing direction, both are equal means it will become negative. Minus IR is equal to 0. From this, how can I write E minus Q by C is equal to IR? And E minus Q by C is equal to, instead of I at a particular time interval t, in that case the I also written as dq by dt multiplied with R. If you observe this one, how to write this one? EC minus Q by C is equal to dq by dt multiplied with R. Till now, is that clear to you? From this, how can I write EC minus Q? If I transpose the R to the other hand, it will becomes RC is equal to dq by dt. But we have to find out the charge Q, and if I will transpose the Q times one side, the T times one side means Q times one side, other times in other hand. How can I write dq by, it will transposing here, EC minus Q is equal to dt by RC. Now our aim is we have to find out the charge value. How to find out? If you integrating on both sides, you will get the Q value. Integrating on both sides. If you integrate on both sides, what will happen? Integral d cube by EC minus Q is equal to integral dt by RC. You have to integrating on both sides with proper limits. Here, what are the limits? We have to find out t is equal to 0 to t is equal to t. With respect to t is equal to 0 to t is equal to t. Here, with respect to charge, q is equal to 0 to q is equal to q. If you integrate these one, now if you observe, it is in the form of, how to integrate this one? Integral 0 to q. I will write 1 by EC minus q into dq is equal to, this is the 1 by RC is the constant, I can take 1 by RC. What the integral of dt? It will becomes t only, or the limits 0 to t. If you observe, it is in the form of 1 by x dx, but it is in the form of q's only. First, I will assume u is equal to EC minus q. Remember, this is the substitution method, and here from this du is equal to minus dq, and by using this dq is equal to minus du. I can use this method for integrating this one. Till now, is that clear? How it will be written as? I can write integral 0 to q. I can consider the total EC minus q is equal to u. From this du is equal to minus dq. By using this dq is equal to du. Nothing but how can I write? Dq means I can write du by, what is the EC minus q? U is equal to, how can I write? Integral 0 to q du by, it will be 0 to q 1 by u du. If you observe, du is equal to minus dq. From this dq is equal to minus du. Here I can use minus, here I can use minus here. It is in the form of integral 1 by x dx. Integral 1 by x dx means log x. Log x plus c, where c is the constant, log x. Here minus, negative type minus. Here instead of x I can write u. It will becomes minus log, what is the u value here? EC minus q. Is that clear? If you have confusion, just follow this procedure. I can consider u is equal to EC minus q here. Du is equal to minus dq. From this dq is equal to minus du. Just by substituting the values, it is in the form of 1 by x dx. Here x is equal to u. From that I got minus log EC minus q. Finally, I can write minus log EC minus q. What are the limits here? 0 to q is equal to, here t integral 0 to t, it will becomes t by RC. Till now, is that clear to you? Now, it will be total having the limits 0 to q. Is that clear? It can also written as, if you multiply total equation with negative sign, I can write ln EC minus q integral 0 to q is equal to minus t by RC. If I apply limits here, it will becomes ln EC, the upper limit, it will becomes minus q minus ln, the lower limit is 0. it will becomes ln EC is equal to minus T by RC. Is that clear? Now it is in the form of log A minus log B. How to write this one? ln EC minus Q by ln of EC is equal to minus T by RC. If you observe this one, log A by B, it will becomes like this, ln EC minus Q by EC. If you transport the logarithm to this side, it will becomes EC minus Q by EC is equal to log. If the log is transferred to other hand, it will becomes exponential e power minus T by RC. From this, how can I write? 1 by Q by EC is equal to e power minus T by RC. From this, I can also written as, if I transpose the e power minus T by RC that side, it will becomes 1 minus e power minus T by RC is equal to Q by EC. From this, Q is equal to the EC transferred to other hand, EC multiplied with 1 minus e power minus T by RC. Is that clear? This is the formula for charge accumulated on the capacitor at a time interval of T. Is that clear? This is the formula for charge. By using this formula, at any time interval, you can find out the charge. If for suppose T is equal to 0, T is equal to infinity, at any time interval, you are able to find out the charge. Let us try how to apply this formula. Till now, is that clear? Now, where Q is equal to what you got? EC multiplied with 1 minus e power minus T by RC. If you observe it properly, if the exponential power x means x is not having any dimensions, nothing but this term is not having any dimensions, nothing but minus T by RC is a dimensionless quantity, it is a dimensionless. How to it will become dimensionless? If the T dimensions and R dimensions both are equal, that time only both are cancelled to each other, it will become dimensionless. Nothing but here the dimensions of RC is T only, because e power x, the x is not having any dimensions. If it is a dimensionless quantity, the RC dimensions also must be equal to T. Is that clear? Here RC is called as time constant. RC is called as time constant, and it is represented by tau. It is represented by the letter tau. Is that clear? Here the dimensions of RC is T only. Here RC is called as a time constant. It is represented by tau, and it is also written as Q is equal to EC multiplied with 1 minus e power minus T. Instead of RC, we can also written as tau. Is that clear? Now if you observe carefully, what is the term EC? EC means what? Where EC is the maximum charge. Where EC is the maximum charge. We already know that whenever the T is equal to infinity, the Q becomes Q naught. What is the charge here? How to write the charge? If you take the same circuit, just observe it one more time. What will happen? Here Q becomes Q naught means it is G. Here also it is G. How can I write Q is equal to, what is the formula? C is equal to Q by V. V is equal to Q by C. Here, how can I write Q is equal to, the Q becomes maximum charge Q naught by C. Here Q is the maximum charge. From this, here V is nothing but here the EMF E. EMF E is equal to Q naught by C. From this, Q naught is equal to EC. Where instead of EC, I can write Q naught. Is that clear? Instead of EC, EC is also called as maximum charge on capacitor. 1 minus e power minus t by tau. Is that clear? Where Q naught is the maximum charge. Is that clear to you? You can written here EC is equal to Q naught, where Q naught is the maximum charge. Maximum charge. Now, I am already told you, by using this formula, you can find out the charge at any time interval. Per suppose, the time interval t is equal to 0. If t is equal to 0, what will happen? Q is equal to Q naught multiplied by 1 minus e power minus t. It will becomes 0 by tau. E power 0 is equal to 1. 1 minus 1, it will be 0. Nothing but Q is equal to 0. In first case, if t is equal to 0, Q is equal to 0, the condition is satisfied. Is that clear? For suppose, if t is equal to infinity, what will happen? Q is equal to Q naught into 1 minus e power minus infinity by tau. Now, e power minus infinity, what is the value? E power 0 is equal to 1. Just remember, e power 0 is equal to 1. E power minus infinity, it will become 0. The total 10 becomes 0. Q is equal to Q naught. The third case, if t is equal to infinity, Q is equal to Q naught, the maximum charge, it is also satisfied. By using this charge formula, we can find out charge at any time interval. Is that clear? For suppose, if t is equal to, if t is equal to tau, if t is equal to tau, what will happen? Q is equal to Q naught into 1 minus e power minus tau by tau. Q is equal to Q naught into 1 minus e power minus 1. Is that clear? See, if t is equal to 0, Q is equal to 0, satisfied. If t is equal to infinity, Q is equal to Q naught, it is also satisfied. If t is equal to tau, what will happen? Q naught is equal to, nothing but Q is equal to Q naught into 1 minus e power 1, e power minus 1. This is also written as, this is also written as Q is equal to Q naught into 1 minus 1 by E. We already know that 1 by E value. What is the value? Q is equal to Q naught into 1 minus, what is the 1 by E value? It is approximately 0.37. Is that clear? From this, Q is equal to Q naught into 1 minus 0.37, it will become 0.63. Therefore, Q is equal to 0.63 Q naught, at which case if T is equal to tau, tau is nothing but RC. Nothing but if the T is equal to tau, If the t is equal to time constant of both are equal, the charge, the capacitor charge up to 63 percentage of q naught. The capacitor charge up to 63 percentage of maximum charge. In which condition? If t is equal to rc or t is equal to tau. The tau is a time constant. It is also written as tau is equal to rc. Is that clear to you? T is equal to 0, T is equal to infinity, T is equal to tau. This is the formula. If T is equal to tau, the capacitor charge 63 percentage of its maximum charge. Now, how to draw the graph for this one? How to draw the graph? I will take a x-axis, I will take a time. Y-axis, I can take a charge Q. And here this Q naught represents the maximum charge. Now, if you observe, what is the value of Q? Q is equal to, what is the formula? Q is equal to Q naught into 1 minus e power minus t by tau. Nothing but the graph is in a exponential form. Exponential form means it will increase like this. At t is equal to infinity, both are meeting. And this graph at which point? 63 percentage of Q naught. 63 percentage means more than 50 percentage. At 63, nothing but 0.63 of Q naught, the tau is equal to nothing but T is equal to RC. Is that clear? If T is equal to RC, the capacitor charge up to 63 percentage of the maximum charge. This is the graph for the charge of a capacitor at T is equal to tau. Is that clear? This is the graph for the charge of a given capacitor. This case T is equal to RC is nothing but T is equal to tau, where tau is the time constant. At infinity point, these both are meeting. Is that clear? Now the charge is clear. Now we are going to find out the current. How to find out the current in that circuit? The charge Q is equal to Q naught at T is equal to infinity. For the current at infinity I is equal to 0. At time T is equal to T, Q is equal to Q, current I is equal to I. How to find out current? We know that the current I is equal to dq by dt. If you differentiate the charge, you will get the current. How can I write? D by dt of, what is the charge here? You got the value? Q naught into 1 minus e power minus t by tau. Is that clear? Otherwise you can written as a RC, tau is equal to RC. Now, if you differentiate this one, d by dt of Q naught, it will be constant Q naught. D by dt of 1, it will be 0. If you differentiate d by dt of e power minus t by RC, it is in the form of e power u. How can I write? E power minus t by RC multiplied with d by dt of t by RC. D by dt of t by RC means it will become minus 1 by RC. Is that clear? Now, from this current I is equal to, how can I write? Q naught by RC minus minus plus, you can write e power minus t by RC. This is the current equation. I is equal to Q naught by RC. Now, what is meant by Q naught by RC? Q naught by RC, it is also written as I is equal to Q naught by RC is also written as I naught into e power minus t by RC, where I naught is the maximum current. I naught is the maximum current. Here I naught is equal to Q naught by RC. Is that clear? If the I naught is the maximum current, by using this current equation, you can find out current at any time interval. Let us assume if the T and RC, if both are equal, what will happen? I is equal to I naught into e power minus 1. I is equal to I naught by e. Already we know that 1 by e value. I naught into, what is the 1 by e value? 0.37. From this I is equal to 0.37 I naught. In this case, if T is equal to RC, the I is decreased by 37 percentage of I is decreased by 37 percentage of its maximum value I naught. Is that clear? 37 percentage of I naught. If you observe, in first case, the charge is increased by 63 percentage. If the charge is increased gradually, the current is decreases in the circuit. If the charge Q is increases, the current I is decreases. In this case, the current decreases by 37 percentage of its maximum value. Is that clear? And now, how to draw the graph of a current? How to draw the graph for the current? In same way, an x-axis I will take time period t, and y-axis I can take current I, and this is I, and this is the maximum current I naught. Here what will happen? The current decreases gradually. The current is decreases. Now, if at a particular point, if T is equal to RC or T is equal to tau, T is equal to time constant, it is decreased by 0.37 into I naught. It is decreased by 37 percentage of maximum value, maximum current value. It is clear, at infinity it will meet. This is the graph for the current. It is decreased by 37 percentage of its maximum value at which point? Where T is equal to RC. Is that clear? This is the equation for current and equation for charge. Till now we are finding the charge equation and current equation. Now how to apply these equations while solving the problems? Till now is that clear? While the capacitor is charging, the Q increases gradually because it will be stores charge. The current decreases gradually. The charge increases, the current decreases. Is that clear? Now let's solve one problem for better understanding. Let us consider one sample circuit here. Resistor, capacitor, it is connected to a cell, and this is switch. Let us assume resistor 2 ohms, the capacitor 3 farads, and the potential difference you can write as EMF of the cell E is equal to 10 volts if the switch is closed. Now, by using those two formulas, what is the first formula? Q is equal to Q naught into 1 minus e power minus t by tau. Or the another formula, or the current formula, I is equal to I naught into e power minus t by tau, where tau is the time constant. Is that clear? Now, we want to find out how much current flowing through the circuit at t is equal to 0 as well as t is equal to infinity. We have to find out the charge and current at the time interval t is equal to 0 as well as t is equal to infinity. At t is equal to 0. At t is equal to 0, what is the charge? Q is equal to Q naught into, we have the formula 1 minus e power minus t by, instead of tau I will write RC. If t is equal to 0, if you substitute the value, q is equal to q naught into 1 minus, it will become e power 0. E power 0 means it will 1, 1 minus 1, it is 0. It will become q is equal to 0. Is that clear? At a time interval t is equal to 0, q is equal to 0. What about the current? Current I is equal to I naught into e power. Here also same. What will happen? T is equal to 0, 0 by tau. What is the current here? E power 0 is equal to 1. I is equal to I naught. What is the I formula? Generally, V is equal to IR. Therefore, I is equal to V by R. Here, from this I is equal to, what is the V here? You can take a EMF 10 by 2. From this I is equal to 5 amperes. The maximum current flowing through the circuit whenever the t is equal to 0. Is that clear? At t is equal to 0, the current I is equal to 5 amperes, the charge q is equal to 0. After closing the switch S. Now, first suppose if t is equal to infinity, at t is equal to infinite value, at t is equal to infinite, what will happen? Q is equal to, you know that formula, q naught into 1 minus e power minus t by RC. Here q is equal to q naught into, just observe carefully, e power infinite, e power 0 is equal to 1, e power infinite is equal to 0. It will becomes q is equal to q naught. What is the formula? Q is equal to, we have the formula, C is equal to Q by V. From this Q is equal to C into V. Here Q is equal to, what is the C value? 3. What is the EMF? 10. At t is equal to infinity, the Q is equal to 30 coulombs. In same way, the current is increases, 0 to infinity, the charge is increases. What about the current? I is equal to I naught into e power minus t by RC. Here what will happen? I is equal to I naught into e power minus t. T, instead of t you can write infinity, e power infinity. What will happen? E power 0 is equal to 1, e power infinity is equal to 0. It will become I is equal to 0. If you observe, at t is equal to infinity, the capacitor acting as a open circuit, there is no current flowing through a circuit, I is equal to 0. Is that clear? In this way, we have to utilize these formulas, the Q and T. In next session, we will going to explain the discharging process of a capacitor in an RC circuit. Like that, we have to find out the charging process of a capacitor in an RC circuit. Is that clear? And here you have to remember one point. Whenever the t is equal to infinity, q is equal to q naught, I is equal to 0. In this case, there is no current flowing through a circuit. This state is called steady state. Is that clear? This state is called steady state. If there is no current flowing through the circuit, the state is called steady state. In this RC circuit, if the charge increases, the current is decreases gradually. Is that clear? Thank you. Thank you all of you.